Well, we're still dealing with the ambiguous case where we've got side-side angle, where we're looking to solve a triangle. And this time it's talking about two solutions, so I'm thinking that we're going to predict that we've got two solutions. What do you think? Well, let's see. We've got angle A, which we know is 38 degrees, and side A is 8, and side B is 10. At least we got these things put in order. We didn't have to move them around like we did the last time. And I can see that A is less than B, and we're still going to need to calculate H, because we got to compare side A to the height. And so H is equal to the height of this triangle is equal to the side B, 10, times the sine of 38. We got to compare that to side A. So let's see. 10 times the sine of 38. And that's approximately, H then is approximately equal to 6.2. Now, what's A? So A then is greater than 6.2, which I'm looking across the chart here for this acute angle. A is less than B and less than H. That's not us. A is less than B equal to H. That's not us. A is less than B and A is greater than H. That's ours. Two solutions. Now, what this means is that angle B in this case could be an acute angle, but it also could be obtuse. And we have to think about it both ways. So, first off, we're going to do it as if it's an acute angle. Then we'll work on it in case it happens to be obtuse. So to begin with, we're just going to set the sine of A over side A is equal to the sine of B, which we're trying to find, over side B, which is 10. And so 10 times, and the sine of A is 38, 10 times the sine of 38 divided by 8. The inverse of that is going to give us angle B. So let's see, let's work through that. So we got 10 times the sine of 38 divided by 8. And then we're going to take the inverse sine of that amount. And we're rounding this to the nearest degree. So we say, okay, well, angle B could be 50 degrees. Could be. All right, well, let's see. Then all we got to do is find angle C and side C. Well, if this, in this case, with B, angle B being acute, we could take 180 minus 38 minus 50, and that's going to give us angle C. 180 minus 38 minus 50. I didn't put that in right. 180 minus 38 minus 50. 92. So angle C is 92. Well, okay. Let's find side C. We're going to stick with what most we know, which is we've got the sine of 38 over 8 equals the sine of 92 over C. Let's see, and then C is going to equal the sine of, approximately, the sine of 92 times 8 divided by the sine 38. Let's try to make that look a little better, 8. All right, well, let's see what that equals. So we got 8 times the sine of 92 divided by the sine of 38. And rounded, that's 12.98. So if we round that, then side C is equal to approximately 13.0. All right, that sets us up if angle B is acute. But what if angle B happens to be obtuse? Well, if it's obtuse, we can take 180 less 50. In other words, it's either going to be 50 or it's going to be 180 less 50 for angle B. So in our second case, we're going to write right here, second case, then B would be 180 minus 50 or 130. And what I did is I just took what we originally found for angle B and I subtracted it from 180 and said, okay, if it's not 50, then maybe it's 130. Now we already know what side B is, it's 10. That doesn't change. What is going to change, in addition to angle B, let's put this is equal to B, would now be what is C, angle C, where before we said it was what, 92. This time we'd have 180 minus 38, that was angle A, that's not changed, minus 130. So angle C then is going to be approximately, let's say 180 minus 38 minus 130, 12. So C could also be 12 degrees. And now to finish this off, we just need to find side C when angle C is 12. And I'm just about out of room. Let's see. We'll kind of put this off like this. So now we got the sine of 38, that we were given that, over 8, side A, 8, we were given that. Now times the sine of 12 divided by side C. Such that side C, and I hope you can check my math on this, is equal to 8 times the sine of 12 divided by the sine of 38. And I need my calculator. So we got 8 times the sine of 12. And we're going to divide that by the sine of 38. And that equals rounding 2.7. So side C is equal to approximately 2.7, whatever our unit of measurement is. So in our first case, we were given that angle A is 38, side A is 8, angle B is 10. We used the law of sines and said, okay, well, angle B could be 50. We know we've got two possible solutions because we know that side A was less than side B. 8 is less than 10. We solve for a value of H, which we found to be 6.2. And side A being 8 is greater than 6.2, so we know we got two solutions. Once we had our possible solution of angle B being 50, we calculated angle C by taking 180 minus 38 minus 50, gave us 92 degrees. And then we went about to find side C if angle C happened to be 92 degrees, and we determined that was approximately 13. Then for our second case, we said, well, if angle B is not 150 in this scenario, it must be 130. We get that by taking 180 and subtracting our original finding for angle B at 50. At 180 minus 50 gives us 130. So now we got a second scenario where angle B might be as much as 130 degrees. And then we set out to find, okay, well, under that scenario, what would angle C equal? Well, that's 180 minus 38 minus 130. And in that case, it would be approximately 12 degrees. And then going back to what we knew, which was angle A being 38, we took the sine of 38 divided by side A we were given at 8. Set that equal to the sine of 12 to find side C when angle C is 12. and that came to 2.7. All right, probably need to see one more of these. All right, so here we got another case. We got angle A is 65 degrees, side A is 57, side A is 55, and side B is 57. Well, 55 is less than 57, and let's find our height. We want to compare that to side A. And so we're going to do that by taking side B, which is 57, and multiplying it by the sine of 65, which is what we're told angle A is. And so let's see, 57 times the sine of 65, and that equals, in this case, H would approximately equal 51.7. Well, 51.7 is less than side A, which means we're still into this scenario here where A is less than B and A is greater than H. 55 is greater than H. 55 is greater than 51.7, which means we got two possible solutions. All right. Let's go ahead and let's see, okay, what if angle B is in fact acute? And we're going to work on it on that basis. So I'm going to take the sine of 65, divided by side A, 55. And I'm trying to find the sine of angle B, if it is acute, divided by 57. And so then we're going to end up taking the inverse sine to find angle B of 57 times the sine of 65 divided by 55. All right, 57 times the sine of 65 divided by 55. And I want to take the inverse of that. Inverse sine, second answer, parentheses, boom. And if I rounded that to the nearest degree, then angle B would equal 70. Should it happen to be an acute angle. And 70 is an acute angle. Now, we might as well go ahead and find angle C. In this case, we take 180 minus 65 minus 70. And so angle C is going to equal 180 minus 65 minus 70, or 45 degrees, possibly for angle C. And now let's find side C under that, in that case, by taking the sine of 65 divided by 55, and then the sine of 45 to find side C, which is going to, it means that C is going to equal, let's say, 55 times the sine of 45 divided by the sine of 65. All right, 55 times the sine of 45 divided by the sine of 65. And so angle C, side C would equal approximately 42.9. All right, there's our first scenario. Now, once again, angle B could be obtuse. And how much could it be if it is obtuse? Well, I can take my original finding for angle B and subtract it from 180. And in this case, angle B would be obtuse, and it would be 110 degrees. So angle B could also equal 110 degrees if it was not 70. Okay, well, now if it's 110 degrees, and angle A hasn't changed, it's 65. What would be left for angle C in our second case? Well, I take 180 minus 65 minus 110. And angle C in that case would only be 5 degrees. Let me make a bigger C there. So angle C in that case would be 5 degrees. Well, it's going to be a small angle, isn't it? Means it's going to have a fairly small side. Well, let's find, in case number 2, let's find what side C might be. And again, I'm going to do my setup. I got the sine of 65. I want to use as many things as they were given to me as possible. Over 57 equals the sine of 5. No, 55. Sine of 65 over 55, not 57. 55. I knew that didn't look right. Over side C. Then side C is going to approximately equal 55 times the sine of 5 divided by the sine of 65, such that C will approximately equal, all right, 55 times the sine of 5 divided by the sine of 65. And if I round that to the nearest tenth, that would be 5.3. All right, again, just a real quick recap. We were given the fact that angle A was 65 and the side opposite it, side A, was 55, and the side adjacent to it was 57. This prompted us to find angle B using the law of sines, which I took the sine of 65 over side A, that's the sine of A over side A, sine of 65 over 55, set it equal to sine B over side B, which was 57, and then taking the inverse sine of 57 times the sine of 65 divided by 55, and that gave me possible angle measure for angle B of 70. And from that, we calculated a possible measure for angle C, which was 180 minus 65 minus 70, which left 45 as a possibility for angle C. Went back to what we knew about the angle A and side A, so we took the sine of 65 divided by 55, set that equal to the sine of 45 over side C, which was what we're trying to find, such that side C would then be equal to the sine of 55 times the sine of 45 divided by the sine of 65, which came to a measure of 42.9. To evaluate our second case, we said, well, if angle B is not 70, what might it also be? And we could calculate that by taking 180 minus 70, which gave us 110. We said, okay, in case 2, angle B might be 110. Now, side B is not changing. It's 57. Doesn't matter whether it's 70 or 110. It's still valid that its measure is 57 in whatever unit of measurement we have, when we weren't told, actually. And said, okay, well, if side B is 110, angle B, if angle B is 110 and angle A is 65, in that case, what would be left for the measure of angle C, which was only 5 degrees? And then to find side C, we go back again to things we were given, which was the angle 65, side of 55. So we set up the sine of 65 divided by 55, side A, equals the sine of angle C, which we said could also be 5, over side C, which is what we were trying to find, such that side C would be equal to 55 times the sine of 5 divided by the sine of 65, and from that we said C would be approximately 5.3. I would tell you I love these ambiguous cases. Maybe when I get to the end of it, I actually do like it. When I'm in the middle of it, not so much.